Hello and happy Thursday. Here's our video for today. I want to go over some review and new stuff, like what this says. Review, weathering, erosion, and deposition. New stuff talking about rapid and slow processes that change the Earth. All right, take a look at this picture here real fast. Do you see any evidence of erosion? Do you see any evidence of weathering? Do you see any evidence of deposition? If there's someone in the room, tell them what you notice. If you are doing this alone, talk to yourself. What are those three things you see there real quick? Go ahead. Okay, if you are seeing that you're seeing evidence of erosion, possibly the water here of the ocean taking some of the sand away, moving some of the sand and rock away, that's a good example of that. That wave action could happen with that. Weathering, great example of weathering could be this large boulder that possibly fell from this opening right here. It broke off, weathering, erosion, falling, right? And then deposition, great example of deposition right here, that boulder, the sand being left behind where it is right now. I showed you these pictures way back at the beginning of all this. These were pictures I took from last year, and I asked you the question of, are these pictures in the correct order? And again, if you have someone in the room with you, you can pause here and talk to them about this real quick, or you can talk to yourself or your dog or your cat, whatever you want. But are these in the correct order? If you said no, you are correct, right? This is where our landscape would have started. The second picture would be this one right here. You can notice there is a little bit of weathering and erosion going on right here and a small amount of deposition. And then here, after we've poured in more water, we have much more deposition. The sediment's been weathered here, broken away, moved, erosion, left behind, deposition. Good. All right, and then here, where do you see erosion? Where do you see deposition? So you can kind of see, you can see proof of erosion, right? You can see proof of what's caused that erosion, the water, and you can think back to the examples that we saw in our homeroom. So this is where I was talking about before. You did not see this landscape last year, but you saw our landscape and you're connecting it to this one that you were not present for, which is what we do in geology when we study these things. We make observations of what we can see now, and then we apply those to the places that we're studying that we were not there to see what was happening with that. All right, new stuff. So in your notes, this is where we're going to be writing some of the stuff down. Rapid and slow processes. Okay, here's the thing. The Earth's surface can change slowly and rapidly. I want you to write that sentence down. And if you need to pause this, pause it. I'm going to kind of go through so the video is not 400 hours long. So pause this if you need to. The Earth's surface can change slowly and rapidly. A slow process, these changes take a long time. Now, when we're talking about time with us versus the Earth, we have to change how we think about it. For example, I feel like we have been in quarantine for a long time. But when it comes to history of the Earth, this is nothing. When we're talking about slow process in the Earth, we're talking about tens of thousands of years, millions of years, and in some cases, billions of years. So we need to think of it this way. A fast process or a rapid process, these things happen very quickly. And when I'm talking about quickly, I'm talking about some things that could happen like in 100 years, because 100 years for us is a long time, but for the Earth, 100 years is nothing. Or it could happen over a period of months, weeks, or even in a day. Those are rapid processes. So slow process, rapid process. If you need to pause it so you can write this down, this whole screen that I'm zooming around right here, you can do that. All right, so let's get some examples. I want you to write down these examples. Slow processes, right? Rivers forming canyons. This is the Grand Canyon. We were looking at that for a national park video a couple weeks ago. I think it was last week, actually. This is a slow process. Water carving through all the layers of stone took millions of years. This is not going to happen quickly at all. So rivers forming canyons, that is an example of a slow process. Another slow process is wind erosion. And here's our arch from Arches National Park in Utah. We also talked about that If you imagine back when we did our stations with the coffee stirrers and the sand, if you imagine how long it would take for you to blow sand across stone to carve out this archway, that would take a really, really long time. This is another slow process. And here is another one. Slow process is glaciers. This is a picture of a mountain glacier, a current one. We were going to be talking a lot about glaciers on Friday because they are very important when we're thinking about our state and everything about our state. So here we have this field of snow and ice where we get a nice amount of snowfall and a good amount of melting. It's a perfect combination. And if you imagine when you have a car that drives over snow, it will pack it down and get that real kind of slick, smushy, slippery ice. That eventually is what happens on these bottom layers over millions of years, and it's going to start pushing its way down the mountain and act like a bulldozer of ice, but it's a very slow bulldozer of ice. Glaciers are really slow. I mean, they move slowly. The changes they make are slow changes, but unfortunately, if conditions are wrong for them, they can melt quickly. And we're going to talk about that on Friday. To give you a scale of this, down here, I don't know how well you can see, but this dot right here that I'm moving up and down, these are people down here. To give you an idea how big this thing is, there are two people walking side by side, and these other dots down here may also be people, but I know those two are people. So it gives you an idea of how much ice, and this is just the terminal edge of a glacier. There's a lot more pushing this down. This is the end of it. All right, so just as remember, slow processes take a really, 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 really long time to happen. Rapid processes do not, okay? For example, a rapid process. So these are some things I would want you to write down. And like I said, if you need to pause me and you can write this down. Volcanic eruptions. This is a volcano here in the United States. This is in Washington State. This is Mount St. Helens that erupted in May 18th, 1980. So this erupted a few months before I was born. This is what it looked like. And then the next week, basically, this is what it looked like. Mount St. Helens blew itself in half in one day. And the reason why I would say in 1 week, this is what it looked like, because that's pretty much how long it took for the ash and smoke to clear out of the way so people could see what it would look like. Maybe this is even longer, because it took a while for plants to come back. This place was obliterated within one 24-hour period, just destroyed everything. So seeing these plants growing here, I need to go back on what I said. This is probably several months or maybe even several years later where these plants are finally growing in to this area. So you can see forest, no forest, nice triangle-shaped volcano, smoking crater. This happened quickly. This was not a slow process at all. Another one is earthquakes. Right here is a picture from the San Francisco earthquake that happened over 100 years ago, and was this devastating to the city of San Francisco, especially since we had no way of predicting when earthquakes were going to happen. There was even an I Survived book written about that. So earthquakes, also a very fast, rapid process. Here's a before and after of a home that has been damaged by earthquakes. You can take a look at that. Another example of a rapid process is a landslide. Maybe you noticed some of that happening in the videos I posted early on about our landscape when we went on quarantine. I posted some videos. If you didn't watch them, go back and watch those. I added a lot of water. If a hillside is saturated with water in a short period of time, there is a potential for a landslide, and it can be devastating. You can see how it just came across and just destroyed these homes, covered the street, and tons of earth that have to be cleaned up. And now this area is going to be more likely to have more landslides as well. So again, rapid process, quick change. And here's another one, rapid process coastal erosion. Now I noticed, here are the dates, 1996 to 2012. But again, you need to think about it in the time period of the Earth. This is not slow. This is a pretty quick change. So we see this happening along the coasts, so east coast and west coast by the oceans. The action of the waves and the movement of the water are going to break away the coast and move it down and make another part of the coastline later on. So just take a moment, pause this video, study those pictures, and see the changes. Notice this wall right here that kind of goes down here. I don't know if that's a wall that was built to try to stop this erosion, but there it is there. And now it's submerged underwater. So you can imagine, I kind of wonder what this area looks like now in 2020. Here's another one, August 2012, and then this is November 2012 after a hurricane. Hurricane Sandy hit up the east coast around the New York area, and you can see that within one hurricane, the amount of weathering and erosion that took place. Look at this beach, and basically the beach is gone, right? But I mentioned this in one of my videos earlier on, that while something like this is being destroyed, we need to keep in mind that something else is being created. So this sediment is being moved further down the coast and possibly creating another sandbar, something further down the coastline. Here's another picture. When they built that house, it was not hanging off the edge like that. It would have been built on land, whether, although it was sand, and because of these storms, washed away. Here's another one. These are fast processes. Within 2 years, take a look at this. Basically 2 years. Here you go. And now look at the difference. These are fast processes. Rapid and slow. Just another reminder. The Earth can change its surface slowly or rapidly. So here it is again. If you need to write it down, if you have it written down, you're good. You don't need to write it down all these times. I'm just reminding you. Slow process takes a long time. Rapid process happens quickly. All right, so I want to show you this real quick. This is, if you've ever been to portions of Kentucky, specifically around Mammoth Cave, you would see this landscape if you were looking out your car window, if you could see it. What I want to do here is I want to give you some interesting examples of rapid and slow processes. This is something Kentucky is well known for, because Kentucky has a lot of caves, and it has a lot of caves because it has a lot of these things. So if you take a look at these little dips in the ground, these are what we would see above ground with a sinkhole. And what's neat about sinkholes is they happen slowly, they form slowly, but then when they let go quickly. So they're kind of in between a rapid and slow process. Here's what's going on. Over time, water seeps through the ground. So imagine this is the soil, and seeps through the ground, goes down into the bedrock, into the rock. And Kentucky has a lot of limestone, so it's easy for this to happen. And that water weathers away the rock. So for years and years, the rock underneath the soil is being weathered away. And meanwhile, if you and I were standing up here, we would have no idea what's going on below ground. And then all of a sudden, it lets loose. So this is something that's taking hundreds of thousands of years, hundreds of years, maybe thousands of years, depending on the circumstances. And then within a matter of seconds, it drops down. Imagine when you've been playing in the sand, for example. Maybe you guys have played at the beach or in a sandbox, and you do that whole thing where you try to dig out the sand underneath and then wait for it to collapse on top. If you know what I'm talking about, that's what sinkholes do. So this is what happens, for example. This sinkhole was forming underground for a really long time, and then it just let loose in the middle of the street. Here is another example. And hopefully whoever was in this car is okay. So again, sinkhole is forming underground, and then it finally lets loose. Now this video here, I'm going to put this in the Google Classroom. I'm going to put these videos in order. I'm not going to show them to you here because the resolution would be terrible. But this video right here is of a sinkhole that opens up in a swamp. So this is really cool to see what happens when a sinkhole opens up in a swamp. You have to watch this video. It is really neat to see what happens. and they knew it was going to happen, so they had marked off the area so people wouldn't go boating in there. And it's a good thing they did, because otherwise it would have been bad news for people in that area. So watch that video there. Okay. Um, the other thing, interesting thing about sinkholes is Corvettes. Corvette is a really nice sports car. There's only one manufacturing plant for them that happens to be in Bowling Green, Kentucky. Corvettes are really, really expensive, and there is an interesting history with them and sinkholes. So this other video, again, you have to watch this, because here's what was going on with this. It was, I can't remember the year, but basically the middle of the night, the security alarms go off inside of this museum that they have for the Corvettes, because Corvettes are, like I said, are really expensive sports cars. They're collector's items. They've been made for years now. So imagine a museum that is full of essentially priceless sports cars. Alarm goes off. People figure out what's going on. And this is a video of what happened that the security cameras caught when no one was there, thankfully, because if the museum was open and people were there, it would have been bad news. But basically, when they got there, this is what they saw. These are priceless automobiles at the bottom of a sinkhole that had been forming underneath of the museum for years, and no one knew about until the security alarms went off. So if you want to see the video of this happening, you should watch it. These are not toys, even though they look like it. These are priceless sports cars. Some of them could be saved. Some of them were just completely totaled. So here's another interesting thing on earthquakes. There's another video that we'll watch about earthquakes. Earthquakes are a rapid process. It's neat. Ralph Waldo Emerson was a famous poet, American poet, and he said, "We learn geology the morning after an earthquake." So if you remember the word geology, what that means, earth study, he's saying, look, the day after an earthquake, we learn about the earth. Which is really amazing. When he's true, right? When we experience an earthquake, we learn about the earth. So this video here is going to take you to this page here. Check this out, because this teaches you about earthquakes, right, and how they form and everything else. This is a lot of information I'm giving you quickly, just because of our circumstances. But this is stuff that I want you guys to check out, and just watch it and just learn about it. You'll learn more about earthquakes in 7th grade, I think. Definitely middle school. I think it's 7th grade. So I don't want to steal too much of their thunder, but watch this, and you'll learn more about them that way. So earthquakes, we rate them on something that's called a Richter scale. Insignificant. Sometimes there's earthquakes that happen and we don't even know they happen. They are insignificant up to, sorry about that, up to extraordinarily damaging, where it's just utter destruction. Here's a picture of San Francisco earthquake. San Francisco earthquake, I think, was a magnitude 8 or 9. Massive, massive devastation. It almost destroyed the entire city. With the buildings here, you can see have crumbled apart. Buildings caught fire as a result of it. Just a terrible thing. You can see the street split apart here, literally split, because in some cases, that's how earthquakes work. They will move back and forth. So if you watch this video here, this video goes over basically how earthquakes work. So we'll just take a look at that one real quick. So sometimes the earth will slip like this, and that will be an earthquake. The earth will slip in the opposite direction. That will happen. That's where they're forcing into each other and they slip like that. You see my hands at all? This is where the crust would be sliding back and forth like this. And we have evidence of that changing rivers. We can see extinct river plains like that. That's where it's pulling apart. All right, so just a quick video on that, on earthquakes. Here's another picture from the San Francisco earthquake at that time. You can see where the ground shifted and pulled the street and the tracks with it. Here are three different ways. So convergent is where the crust is pushing against each other, pulling apart, or sliding back and forth. Here's a more modern day. Well, this is kind of an older photograph of that slip fault where it's pulling the tracks apart this way. Here's more damage. So this is rapid changes. I want to go back to the word on that. These are quick and rapid changes of the earth from earthquakes. This is images from a devastating earthquake that happened in Asia a couple years ago. So this is what the area looked like before and then after. So this is within a 24-hour period. Not even really that. I mean, earthquakes last just a matter of minutes and then it's done. So this is the damage that happens from an earthquake. And like I said, you're going to learn a ton about earthquakes in middle school. So one of the things here that I want to leave off on this video so it's not too terribly long is this idea of what is causing this to happen. So this is a map, and I had a map in my classroom that marked this, marking where we feel these plate boundaries are. So if you remember back, I think you guys learned about this in third grade science with layers of the earth. You have the crust, you have the mantle, and then you have the core. The crust is the rocky outer layer of the earth that we are on right now, but that is not a solid rocky layer. It is broken into pieces. And these lines represent where those pieces meet each other. And sometimes they're going to meet each other where they slide back and forth, like right here, where the crust is going to be sliding back and forth. San Francisco and California experiences a lot of earthquakes because of that. Or where you have where it's pushing into each other, like over here with these plates. But each of these red dots are major volcanoes. Not all of them. That would be, I think, nearly impossible because some volcanoes are quite small. But these are major volcanoes. And where you see these plates meeting, you're going to see volcanoes and earthquakes. And this idea came across this person right here. His name was Alfred Wegener. And he was one of the first people to really came across this idea, saying there is the possibility that these plates exist. And he had evidence for that. So a lot of people disagreed with him and thought he was foolish, but he stuck with his ideas. And now, years later, we now accept that to be true because of all the evidence we have. So these two videos here, one is a brain pop, okay, that will talk about plates. And then here is a shorter video that does kind of a nice cross section of that. And I will post those as well. So tomorrow, what we'll do, or in my next video, we will kind of go over these volcanoes a little bit more. And we'll talk about volcanoes specifically and where the word volcano comes from, and talk about the city of Pompeii and how that is a great example of a rapid process there. All right, guys, thanks for watching the video. Appreciate it. Hope you're all having a great day, and we'll talk to you later. Bye.